Alrighty, let's do this review. Better put my name there, Mrs. Key. Given relation S consisting of 4 points in the graph below, what is the domain? So domain are collections of input values. So I see -2, I can't make curly braces, I'm sorry, 0 and 2. That was just a parentheses, that wasn't even an attempt. And a range is the y values, the output values. So -2, 0, 3, and 5. Is that a function? That is not a function because when we have 2, 2 goes to both 3 and to 5. That makes it not a function, but you'd have to explain that in words. I explained it verbally. On your quiz, you obviously have to, write things. Identify the domain and range of the relation graph below. Assume the relation continues off the graph. So assume we have arrows. Domain appears to be all real numbers. And the range that goes as high as 2, but keeps going down. So -infinity to 2, include 2. Is that a function? Yes, that's a function. For every input, I only have one output. Given the graph below, sketch -3 times f of x minus 1 on the same graph. So, 2 steps. That says move right 1, and that one says multiply y by -3. So I'm going to start at this point here, move right 1, that goes to 1, and then multiply by -3 on the y, that goes to -3. I'm going to go at this point, move right 1, that goes to 2, and then multiply by -3, that goes to -9, so somewhere down here. I'm going to go with this point here, move right 1 goes to 0, multiply by -3, that goes to +3. I think that's about all I can do, because otherwise those points are going to go off the graph. It will look something like that. So your explanation is explaining this movement. And this next one, same idea. We're going to wind up going right 1, multiply y by -1, and then go down 3. And that's the order in which I have to do that. So if I start here, if I go right 1, it's going to wind up, I could use this little piece, couldn't I, to show you what's up. So if I'm here, move right 1, and then I got to multiply by -1, so that's going to be -2, and then down 3. So that'll go down to -5. I should fix that graph for you. Perhaps I shall. So that'll be 1, -5. And then if I pick another point, maybe I pick this point here. If I go right 1, if I multiply by -1 and then go down 3, 1, 2, 3, then I'm going to go right here. And by symmetry, I also am going to go there. So that's 2, -4. And I will try to remember to fix that graph for you. Ooh, now we have some function stuff. F is defined as the upper, G is defined by the lower. So I'm going to label those because otherwise I'm going to get confused. That's F, that's G. And that one says G of 3, so G of 3 is -1. So I can basically cross out G of 3 and write F of -1. And F of -1 appears to be 0. And then F of 3 appears to be 2, so that basically is the same thing as saying G of 2. And then G of 2 appears to be -3. F times G of 2, so F of 2 is 2. G of 2 is -3. 2 times -3 is -6. F of 0 is 2. F of 2 is also 2. And G of 2 we already established was -3. F over G of 1 times 2 plus 3. So F of 1 is 2. G of 1 is 3 times 2 plus 3. So that's 4/3 plus 3. 3 is the same thing as 9/3. So 4/3 and 9/3 is 13/3. And then, ooh, look at this one. All right, this one looks scary. 2 times f of 3. So f of 3 is 2. So that's 2 times 2. Times 3 times g of 2. G of 2 is negative. Oh, that wasn't that bad, was it? So I got 2 times 2 is 4. 3 times 3 is 9. 9 times 4 is 36 of the negative variety. And that's it.